All right, it's time to get ready for our Unit 11 test. And so for the first part, all we're going to be doing is switching it. And so it started as a logarithmic. We're going to switch it into its exponential form. And so as a reminder, this is our base. This is going to end up being our answer, and this is our exponent over here. So to go from log to exponential, it's going to be base 3 raised to the 4th power equals 81. Number 2, my base is 64. Raised to the 1/3 power equals 4. My base is 9, raised to the -2nd equals 1/81. And my base is 2, raised to the 4th equals 16. Now we'll do the opposite way. We'll start with exponential and we'll change it into logarithmic form. And so it's be log, my base is 2 of 128 equals 7. Log, my base is 27 of 1/3 equals -1/3. Log, my base is 4 of 1 equals 0. And log, my base is 5 of 125 equals 3. Evaluate the following. I mean, technically we could just go ahead and put these in our calculator, but without a calculator, I would think 5 to what power gets 25? That would be 2. In the calculator, just as a reminder, I would go math, scroll up to log base, and then put in the calculator 5 of 25, I get 2. So this one would be 10 to the x equals 1/100. Since it flips over a fraction, we know it's a negative exponent, and 10 squared is 100, so it's -2. 125 to the x equals 5. To make it go smaller, it's going to be a fraction as an exponent. 5 cubed is 125, so I'm going to go ahead and change that base to make them have the same. And so I'd have 3x equals 1, divide by 3, it's 1/3. 81 to the x equals 3. And so again, I'll change the base to make them have the same base. So it's going to be 3 to the 4th. And then x equals 3 to the 1st. And so 4x equals 1, x equals 1/4. And then 9 to the x equals 1. Anything to the 0th power is 1. All right, we're going to sketch the graph of f of x, find the equation of the inverse, and then we'll also graph the inverse. So 1/2 to the x power. On this one, my asymptote is going to be the x-axis, because it doesn't shift up, down, left, right, anything like that. My a value is 1, because there's a 1 in front of that 1/2, so we're going to start 1 away from the asymptote. And because my b is 1/2, we're going to get halfway closer to the asymptote every time I move to the right. Or if I go to the left, I'm going to double how far we are from that. So it's 1 away, then 2 away, then 4 away, 5, 6, 7, 8 away. And so here is f of x, is an exponential function. All right, to find the inverse, I'll switch to x and y. X equals 1/2 to the y power. And then we'll switch it to log. So log base 1/2 of x equals y. So with log, the asymptote's going to be the y-axis. The a value, the number in front of the log, is 1, so we're going to start 1 away from the asymptote. And then because my base is 1/2, it's going to get halfway closer to the asymptote as I go up, and it's going to double as I go down. So 2 away, then 4 away, and then 8 away from the asymptote, everything from the asymptote. Another thing you could do is you can take points and flip them. So this was 0, 1 turned into 1, 0, -1, 2 turned into 2, -1. And so here's my logarithmic graph. All right, going on to the next page. So again, we're going to start with our exponential. So this one is going to have the asymptote on the x-axis. It doesn't shift left, right, up, down. It starts 1 away because there's a 1 in front of that 2. And then my rate is doubling. So it's 1 away, then it's 2 away, 3, 4 away, and then 8 away. We could also go to the left, and it's going to get halfway closer to the asymptote as I go to the left. So there's the exponential function. That's the original. Then to find the inverse, we'll switch the x and y. And then we'll flip it to log. Log base 2 of x equals y. So that's the inverse function. On this one, it's going to be very similar to the last problem we did. The asymptote is going to be on the y-axis. You could take these points and just switch them, or the a value is 1, so we're going to start 1 away from the asymptote, and then we're doubling. Every time I go up, we're going to double how far we are from the asymptote. So it's 1 away, then it's 2 away, then it's 4 away, and then it's 8 away, always from the asymptote. And there's the inverse function. All right, we're going to sketch the graph of the function, identify the transformations, and all those different attributes. So to start off, we're going to go left 6 and down 5. So 1, 2, 3, 4, 5, 6 is going to be my vertical asymptote. And then down 5, 1, 2, 3, 4, 5. This is where I'm going to put like the little crosshair. It's not a horizontal asymptote, that's just where we're going to get all of our other points. And then from there, the a value, the number in front of the log, is 1. So we're going to start 1 away from the asymptote. And because my base is 6, every time I go up, we're going to multiply 6 times further from the asymptote. So this is 1 away, then we're going to be 6 away. 1, 2, 3, 4, 5, 6. The next one would be 6 times 6 would be 36 away, way over here. If I were to divide by 6, I would have 1/6, which is just really close to the asymptote. And so there's my logarithmic graph. The domain, it goes all the way to the left to -6 to infinity. You could also write x is greater than -6. My range is all real numbers. The asymptote is x equals -6. The x-intercept we'll find. The y-intercept we can see 1, 2, 3, 4. So for the x-intercept, we'll plug in 0 for y. Plug in 0 for y. And we'll solve for x. So we'll start off by adding 5 over. And then we'll switch it from log to exponential now that the log is by itself. So 6 to the 5th equals x plus 6. And then we'll subtract 6. So I'm going to go into my calculator. I'm going to do 6 to the 5th power. And then we'll subtract 6. And now we're going to get into solving. So to solve, we want to isolate the variable. Do anything we can to isolate the variable. Since on this one we have a log and then there's no log over here, we're going to get the log by itself, which already is, and then we're going to switch it to exponential. So 5 to the 3rd equals m. And 5 to the 3rd is 125. And then we can always check it just to make sure. So I can plug it in and make sure it checks. And so on this one, I'm going to do log base 5 of m, which is 125, and see does it equal 3? Yes, it does. And so we can check all our answers as we go through it. This one's exponential, so we're going to switch it to log. Log base 4 of 80 equals x. And then I've got to put it in the calculator. Log base, wrong log. 480, so x equals 3.16. To check it, if you did 3.16, it wouldn't be perfect. It wouldn't be 80 on the dot. But what you can do is you can do 4 to the, and I can put in second negative. It does answer, and it does get 80. If I were to put in 3.16, my estimate, it's going to get really close to 80, but not perfect because we estimated it makes it go off a little bit, but it does check. All right, since we have multiple logs, I want to start by condensing my logs. And so I have log base 2. Anytime I see a negative, that means we're going to have a fraction. Positives go on top, negatives go on bottom. So the x is going to go on top. This 3 is an exponent for the 2, and so it's going to be 2 cubed on bottom because of the minus. Over here, this 2 is going to be an exponent for the 10. So log base 2, 10 squared. Now that I have one log on each side, I can cancel out my logs and then solve. And so x over 2 cubed is 8 equals 100. I can put an over 100 there and then cross multiply and solve. And so x times 1 is x. 8 times 100 is 800. and then we can check it again. So to check this one, I just got to make sure the left equals the right. So I'm going to have log base 2 of my x, which is 800, minus 3 log base 2 of 2 equals that. And on the other side, I've got 2 log base 2 of 10, and they are the same thing, so we got it correct. All right, so again, we got to condense first. Log base 3, because there's a plus, that means these are going to be multiplied together. 3x equals log base 3 of 12. Since I have log on both sides, I can cancel them out. 3x equals 12, divide by 3, so x equals 4. I can go into my calculator and check it. Log base 3 of 4 plus log base 3 of 3, and then log base 3 of 12, they equal the same thing, so we got it correct. All right, so there's a log on this side, no log on this side, so you can't just cancel out the log because there's nothing to cancel it out with. And so I'm gonna change it to exponential, so 2 to the 3rd power equals x, and 2 cubed is 8. And we can check that, math, log base 2, 8 equals 3. All right, I'm gonna do 2 things at once on this one. I'm gonna start off by getting rid of this 3. There's multiple things you could do with the 3, but the easiest thing, since I have a 9 over here, we're gonna divide by 3. And I'm gonna go ahead and condense these logs right here. So log base 4, there's no subtraction, so they're gonna be multiplied together. 8x equals 9 divided by 3 is 3. So again, I can't cancel out the logs because there's no log over here. We're gonna switch it to exponential and then solve. 4 cubed is 64. And then we'll divide by 8 to get x equals 8. And then we can check it. 3 log base 4 of my x, which is 8, plus log base 4 of 8 equals 9. On 23, we've got to start off by getting this box, the exponential term by itself. So we're going to add 6, 5, 3 to the 2x equals 55. And then we'll divide by 5. 3 to the 2x equals 11. And then we're going to switch it to log. And so log, my base is 3 of 11 equals 2x. And then to get the x by itself, we'll end by dividing by 2. So in our calculator, we're going to put in the log first. So log base 3 of 11, and then we'll divide that answer by 2. Again, if I put in 1.09, it's going to get close to 49, but not perfect. And so I'm going to go ahead and plug in that answer when I do it. So 5, 3 to the 2 times my answer, so second negative pulls up my answer, minus 6, 49. On this one, I've got a log on each side. They're both just one log, and so I can cancel out my logs and solve. So 3x minus 1 equals 2x plus 3. I'll subtract 2x to each side to get my x's together. So x minus 1 equals 3, and then we'll add 1 over. X equals 4. So on the left side, we're going to have log base 4 of 3 times 4 minus 1. And on the right side, we've got log base 4 of 2 times 4 plus 3. They both get the same thing. It checks. Number 25, we're going to condense it first. We do have a subtraction, which means we will have a fraction. And then this 2 will be an exponent for the x, so x squared, the 3 on bottom. Then cancel out my logs and solve. So x squared over 3 equals 27. If we wanted to, we can put a 1 underneath that 27 as we cross multiply. So x squared equals 3 times 27, which is 81. Square root x squared. And x technically would be plus or minus 9. But when I plug in negative 9 into that x, I can't take a log of a negative. And so x is just going to equal 9. And when I plug it in to check it, I'll have 2 log base 7 of my x of 9 minus log base 7 of 3. On the other side, we have log base 7 of 27. They equal the same thing. Check. All right, on this one, we got to condense first. We have a subtraction, which means we will have a fraction. On top, we have 4x plus 1, and on bottom, we have 3x minus 4. This one does not have log on both sides. I can't cancel out the logs. We're going to change it to exponential. So 2 to the first equals that big fraction. 2 to the first is just 2, and then we'll cross multiply and solve. And so we're going to have 4x plus 1 is equal to 2 times all this. So 2 times 3 is 6x. 2 times negative 4 is 8. And then we'll continue solving. So I'm going to subtract 4x over. I'll come up here. 1 equals 2x minus 8. We'll add 8. 2x equals 9. And then we'll divide by 2 to get x equals 9 halves. Or 4.5, however you want to write it. Because if you were to do 9 divided by 2, that's 4.5, like I said. So I'm going to go ahead and plug in 4.5 whenever I do this. But we'll go up to log base 2 of 4. Oops, I don't need that parentheses right there. 4 times 4.5 plus 1 minus log base 2 of 3 times 4.5 minus 4, and it equals 1. All right, the parent log function is transformed to this will be the transformations from the parent function. So if I were to rewrite this, this f of means we're doing our log function. So it would be, my g of x would actually be 2 log base 2 x plus 1 and then minus 5. So my transformations would be a vertical stretch by 2, left 1 and down 5. So this f means my log function. So again, g of x equals, I've got 1/2 in the front, and then we're doing my function, which is log base 2 of x minus 6 plus 3. So in this we have a vertical compress by 1/2, right 6, and up 3. All right, last page is where we're going to use these formulas up here. And so if you deposit $5,000 in an account that pays 4.5% compounded monthly, how much would you have in 2 years? And so I don't know on this one my final amount. This is my starting amount. And so 5,000, 1 plus, we have 0.045 because you got to change the percent to a decimal. Compounded monthly, that's 12, raised to the 12 times my time, which is 2. And so now I'll just put that in the calculator. So 5,000, 1 plus 0.045 divided by 12, raised to the 12 times 2, or 24. And so A equals 5469.95. However, it says round to the nearest $100. And so that's going to round this number right here. Since that's a 6, it's going to go up. So $5,500. So half-life means we're using this other equation right here on the right. This is my H. It says it has a half-life of 50. How long would it take 1,000 grams to decay to 50 grams? So since it's a half-life, the bigger number is always going to be my original, and the smaller number is going to be my ending. So it's going to be 50 equals 1,000, 1/2, raised to the, I don't know the time, over 50. So we're going to start by getting this box by itself. So we're going to divide by 1,000. And so we're going to have 50 divided by 1,000, which is 0.05. And then we have 1/2 raised to the t over 50. Now that the box is by itself, we're going to switch into logarithmic form. So log base 1/2 of 0.05 is equal to t over 50. And then to get the t by itself is t divided by 50. We're going to multiply by 50 to both sides. So in our calculator, we'll just put this in the calculator as it is. 50 log 0.5 of 0.05 So 216.1, and we're talking about days. If you deposit, that's my original, into an account that pays 9.5, so that's my R is 0.095. I compounded quarterly, that's 4 times. How long would it be before you had $15,000? So we're gonna have 15,000 equals 4,000. 1 plus 0.095 divided by 4 raised to the 4 times t, and I don't know the time. So we're gonna start I'm gonna put this in my calculator, and we're also going to divide by 4,000 at the same time. So 15,000 divided by 4,000 is 3.75. And 1 plus 0.095 divided by 4 is 1.02375. I'm going to go ahead and keep all those decimals so that it doesn't get off too much. And now we'll switch it to log. Log base 1.02375 of 3.75 is equal to 4t. And then we'll end by dividing whatever that is by 4. So we're gonna have log base 1.02375, let me make sure I put that in right, of 3.75, and then we'll divide that answer by 4. And this is years. All right, we're back to half-life. And so how much of a 300 kilogram sample, so that's my original, half-life of 45 would be left after 3 days. So that's my time. However, one thing to be careful of is one of them's in hours while the other one's in days. So I don't know my final amount, 300, 1/2 raised to, I'm going to convert the 3 days to hours. So if you do 3, there's 24 hours in a day, times 24, you'd have 72 over the 45. My variable's all by itself, so we can just put this in the calculator. So 300, 1/2 or 0.5, either way, raised to the 72 divided by 45. And we're talking about kilograms. All right, last question. If 60 kilograms of a 162 kilogram sample, so this is the bigger number, it's my sample, this is my original, this is my final. Radioactive isotope will remain after 13 hours, that's my time. Calculate the half-life, we don't know the half-life. So we're gonna have 60 equals 162, 1/2 raised to the 13 over h. So we're gonna divide by 162. If you press math, enter, it'll convert it to the simplest fraction so that I can keep it as, not round as much as possible. So I'm gonna keep it 10 over 27, 1/2 to the 13 over h, and then we'll convert it to log. Log, my base is 1/2 of 10 over 27 is equal to 13 over h. And then we can cross multiply and solve. So we would actually have h times that log equals 13. And then to get the h by itself, we would actually divide this log over here, 13 divided by that log. All right, so there's all the work of what I'm going to be doing. So I'm going to go ahead and put the log in my calculator first. So log base 1/2 of 10 over 27 equals that. Then we're going to do the 13 divided by second negative my answer. Gets me my half-life. So my h is 9.07, and we're talking about hours. All right, that completes the review. Let me know if you have any questions.